Good morning. In this video, we will see the computation of critical depth and critical velocity. So, we have discussed what is critical velocity and critical depth. Critical depth is the depth of flow of water at which specific energy is minimum. So, we will obtain the critical depth from the specific energy curve, and you can see the point C, which is the point corresponding to minimum specific energy, and the depth corresponding to that point is known as critical depth. And the mathematical expression for critical depth is obtained by differentiating the specific energy equation with respect to depth of flow, which is equating to 0. So in order to make the specific energy minimum, we know at minimum point the differentiation with respect to the depth of flow of specific energy will give you the 0 value, or dE by dy will be equal to 0, and the specific energy equation is y plus q square by 2ga square. So d by dy of y plus q square by 2ga square will be 0. Okay, now let us differentiate this equation. Let small q be the discharge per unit width. So I can write small q is equal to q by b, and consider area as depth into width. So I can write area is equal to critical depth into critical width at specific energy minimum point. Okay. Now I'm applying this capital Q in terms of small q. I can write this equation becomes d by this q square by 2ga will be equal to q square by 2g into, instead of a, I am substituting yc into b. Okay, and then instead of q by b, I am substituting it with small q. So from this equation, I will get the equation becomes small q square divided by 2g into yc square. Now differentiating this equation. Instead of this equation, I'm differentiating this equation. Then when we differentiate, we will get it as 1 plus minus 2 into q square by 2g by c cube is equal to 0. So 2 and 2 will be cancelled. So the equation become 1 minus q square by g by c cube is equal to 0, or q square by g by c cube is equal to 1. And I can write yc is equal to q square by g whole raised to 1 by 3. So what is yc? Yc is the critical depth. So I can write the equation for critical depth when discharge per unit width and gravity is known, then q square by g whole raised to 1 by 3 will be the equation for critical depth. Okay, so we have found out critical depth. Now let us see what is critical velocity. And we know critical velocity is the velocity of flow at critical depth. So we have the equation for critical depth, yc is equal to q square by g whole raised to 1 by 3. So I can make yc cube, that is just taking the cube in both sides, yc cube will be q square by g, or since I'm resubstituting this q back to capital Q by small b, then the equation become, and small q is equal to capital Q by small b, where capital Q is the discharge, which is area into velocity, and we know, we have told that area is width into depth. So width into depth at critical point, that is critical depth. So b into yc into velocity divided by b, which is equal to critical depth into critical velocity. So I can substitute small q as critical depth into critical velocity. Now coming to this equation becomes yc cube is equal to, instead of small q, I am substituting this equation yc vc whole square divided by g, or yc cube is equal to yc square into vc square by g. Here yc square and yc cube will get cancelled, and only yc will left in this point. So yc will be equal to vc square by g, where vc is the critical velocity and yc is the critical depth. So I can write vc is equal to root of yc into g. So the equation for critical velocity is Vc is equal to root of critical depth into center of gravity. Okay, acceleration due to gravity. Sorry. So critical velocity Vc is equal to root of critical depth into acceleration due to gravity. Now let us see the minimum specific energy in terms of critical depth. So we know the equation for specific energy is E is equal to y plus q squared by 2g y square, where small q is the discharge per unit width. Okay, small q is the discharge per unit width. So for minimum specific energy, it will occur only at when depth of the flow will become critical depth. So for minimum specific energy, equation is E minimum is equal to yc plus q square by 2g into y square. Okay, so we know the equation for depth of critical depth, that is yc is equal to q square by g whole raised to 1 by 3. When I take cube of both sides, the equation becomes yc cube is equal to q square by g. And by substituting this equation here, the minimum specific energy equation will become E minimum is equal to yc plus yc cube by 2 yc square, since I am substituting q square by g with yc cube. Okay, so q square by g will become yc cube. So the equation is yc plus yc cube divided by 2 yc square. So yc cube and yc square will get cancelled and there will be only yc left on the numerator. So the equation will be E minimum is equal to yc plus yc by 2, which is yc 1.5 yc, or it can also be written as 3 by 2 yc. Okay, so this is the equation for minimum specific energy in terms of critical depth. So minimum specific energy is the 1.5 times of critical depth. Now let us have a look at critical flow. So critical flow is the flow at which we have specific energy is minimum, or the flow corresponding to critical depth. Or we can also say it will be the flow at which the velocity of the flow will be equal to critical velocity. So when we look at the equation of critical velocity, that is Vc is equal to root yc into g, when we rearrange this equation, we will get the equation as Vc by root gyc is equal to 1. And this Vc by root gyc is the equation of Froude number. So I can conclude that for critical flow, Froude number is 1. And now let us see what will happen to subcritical and supercritical flow. For subcritical flow, we know velocity is less than critical velocity and depth is greater than critical depth. So when we look at this equation, when the velocity is less than critical velocity, that is numerator is decreasing and depth is greater than critical depth, so denominator is increasing. So when numerator decreases and denominator increases, definitely the total value will get reduced, or we can say this will give you a Froude number which will be less than 1. Okay, now when we look at supercritical flow, so for supercritical flow we have velocity which is greater than critical velocity and depth less than critical depth. So when we look at the equation, we can see the velocity is increasing, that is numerator is increasing and denominator is decreasing. And when numerator increases and denominator decreases, definitely the total value will increase. Since the numerator increasing and denominator decreasing, the total value will become greater than the existing value. So we can say the Froude number corresponding to supercritical flow will be greater than 1. Okay, so let us conclude from this specific energy curve. For subcritical flow, the Froude number will give you a less than 1 value, and for supercritical flow, the Froude number will have a greater than 1 value.